Welcome back to Networking Explained, episode 15. Today, we're tackling one of the most fundamental choices in how data moves across the internet, TCP versus UDP. One is reliable and ordered, the other is fast and best effort, and the reason your file downloads and your video calls behave so differently comes down to which of these two protocols they pick. Let's break it down. So here's the core tension. When you download a file, you need every single byte in the right order. Slow is fine, broken isn't, but on a live video call, freezing for 3 seconds to recover a lost frame is way worse than just dropping it and moving on. One network can't optimize for both, which is exactly why we have two protocols, TCP for reliable in-order delivery and UDP for fast, no guarantees streaming. Two tools, two jobs. So let's lock in the one-sentence definition. TCP and UDP are both transport protocol. They ride on top of IP, which handles the actual addressing and routing between machines. The difference is the promise each one makes. TCP guarantees every byte arrives and arrives in order, while UDP just fires packets out fast and accepts that some might get lost along the way. Reliability versus speed, baked right into the protocol. Now, to ground that, let's place them on the stack we built back in the TCP IP episode. Your data starts at the application layer, HTTP, DNS, whatever your apps speak, and travels down. Right below that sits the transport layer, and that's where TCP and UDP live. Beneath them, IP handles addressing and routing, and the link layer is the physical wire or radio. So think of it this way. IP gets the packet to the right machine, but it's TCP or UDP that decides how reliably it actually arrives. So let's start with TCP, because reliability has to be set up before it can be delivered. Before a single byte of your actual data moves, TCP runs a quick three-way handshake, kind of like a phone call. The client says, "Syn, basically, can we talk?" The server replies, "Synac, yes, can you hear me?" And the client closes the loop with ACK, "Let's go." Only then does real data start flowing. Yes, it costs a round trip up front, but that's the price of a reliable channel. Once that channel is open, TCP keeps its promise of reliability through 4 pieces of bookkeeping. Every packet gets a sequence number, so even if they arrive out of order, the receiver can put them back in line. The receiver then sends acknowledgments confirming what made it through, and if an ACK never comes back, TCP simply retransmits. On top of that, flow and congestion control let it ease off when the network is getting crowded. It's a lot of accounting, and that's exactly why TCP costs more overhead than UDP. Now flip that picture on its head, and you've got UDP. There's no handshake, no connection, no acknowledgments, and no retransmission. UDP just wraps your data in a packet and fires it off. If something gets lost or arrives out of order, it doesn't notice and it doesn't care. That sounds reckless, but for live video, voice calls, or fast-paced games, it's exactly the behavior you want, because a late packet is worse than a missing one. So let's put them next to each other and see the trade-offs at a glance. TCP opens with a handshake, guarantees delivery, keeps everything in order, and pays for that with overhead. UDP skips all of it. Just send, best effort, possibly jumbled, but lean and fast. Same network underneath, opposite philosophies on top. Neither one is better. They're built for different jobs. Reach for TCP when the data has to be perfect, and UDP when speed beats perfection. So, where does that actually show up in the wild? TCP runs the things you'd hate to see corrupted: loading a web page, downloading a file, sending email, talking to a database. Every byte has to land in order. UDP shows up wherever a tiny glitch beats a long wait: video and voice calls, live streams, online games, even the DNS lookup that kicked off this whole session. Same internet, two very different jobs. And here's the fun part. In actual code, the difference between these two worlds is one constant. You open a socket and you either pass sock stream for TCP or sockdogram for UDP. With TCP, you then call connect, and the handshake quietly happens behind the scenes. With UDP, there's no connect, and you just send to, and the packet goes. Same two lines of imports, completely different behavior on the wire. Now here's a plot twist that surprises a lot of people. For decades, the web ran on TCP, but that handshake and strict in-order delivery add real latency. So HTTP 3 quietly switched the foundation. It runs on QUIC, which sits on top of UDP and rebuilds reliability in a leaner, smarter way. The takeaway: UDP isn't the unreliable one. It's the flexible base you build custom delivery on top of. And that's a perfect moment to clear up some myths that keep circulating. TCP isn't better than UDP. They're solving different problems, so better depends entirely on the job. UDP doesn't constantly drop packets either. On a healthy network, it's perfectly fine. It just won't notice or fix loss when it happens. And insecure, that's not really a protocol question. Both can be encrypted with DTLS or QUIC. Reliability and security are separate concerns. So, with the myths out of the way, here's a simple way to decide. Reach for TCP when every byte has to land in order. File transfers, web requests, anything where a small retry is better than a missing chunk. Reach for UDP when latency is king and a late packet is already worthless. Live voice, video, multiplayer games. And you're willing to handle any loss yourself at the application layer. Before we go deeper, let's lock in the vocabulary you'll keep bumping into. A packet or datagram is just one unit of data on the wire. The handshake is TCP's three-step setup that opens a connection. And an ACK is the little gated receipt that confirms delivery. A port tells the OS which app the data belongs to. Latency is the delay before it actually arrives. And QUIC is the newer protocol that builds reliability on top of UDP. It's what powers HTTP 3. With that vocabulary in hand, let's pull the big picture back together. TCP and UDP are the two transport protocols you've got to choose from. TCP sets up a connection, keeps everything in order, and guarantees delivery, while UDP skips the setup and just fires packets off as fast as it can. So TCP fits files and the traditional web. UDP fits live calls and games. And neither is better. They're just built for different jobs. Remember, HTTP runs over UDP, so the lines keep getting more interesting. And if you only remember one thing from this whole series, let it be this picture. Think of TCP as a tracked courier. Every package signed for, resent if it goes missing, and handed over in the exact order you sent it, but you pay for that in speed. UDP is more like dropping a stack of postcards in the mailbox. Cheap, fast, most of them land, and you don't sit by the door waiting for confirmation. Hold on to that image, and the rest of the decisions get a lot easier. With that picture in mind, notice how TCP and UDP quietly sit underneath almost every other topic in this series. In TCP IP, they're literally the transport layer. HTTP and HTTPS ride on TCP, while the newer HTTP 3 hops over to UDP through QUIC. DNS leans on UDP for those quick name lookups, and WebRTC uses UDP to keep your video calls and live audio flowing. So once TCP versus UDP clicks, the rest of the stack stops feeling like a pile of acronyms and starts to make real sense. If this episode sparked your curiosity, there's a whole path waiting in the Networking Explained series: TCP, IP, DNS, HTTP and HTTPS, TLS, load balancers, WebSocket, WebRTC, gRPC, firewalls, and VPNs, all building on the same transport foundations. And if you want to go hands-on, the Dargslan networking and security courses take you from raw packets all the way to protection. Everything lives over at dargslan.com/courses. Now, before we wrap up, I've got a quick question for you. Between TCP and UDP, which one surprised you the most? Maybe it was the HTTP 3 twist, where the web quietly moved on to UDP after decades of TCP. Or maybe you've been on a project where you reached for the wrong tool and paid the price. Drop your story in the comments. I read them all. And that's the whole story. Reliable versus fast. TCP versus UDP, two tools built for two very different jobs. If this clicked for you and you want to go deeper into networking from the ground up, head over to dargslan.com, where the full course library is waiting. Hit subscribe so you don't miss the next episode, and I'll see you in the next one.